Hey everyone, Mrs. Spatola here. These are the answers for the prime factorization using a factor tree. So pause the video, check your answers for 6, 7, 8, 9, and 10. As we continue, the answer to number 11 would have been choosing the number 26. Reason why, in this particular problem, you had to add the sum of the prime factors together and find the highest one. So we find that when we add 2 plus 13, that gets us an answer of 15. And you should choose 26 because the sum of the prime factors is 15, and that is the most. Answer to number 12, the error is 9 is not a prime number. The correct answer is 3 to the third power. And finally, here's the answer to number 13. How is finding the factors of a number different than finding the prime factorization of a number? Justify, which means to explain your reasoning with an example. So finding factors of a number is making a list of factors. It's just making a list of numbers, and they are both prime and composite, where prime factorization is finding prime factors only. So that's a huge difference. And if you take a look at the example given, if we had to find the factors of 18, here is a T-chart, and notice the factors of 18 are prime and composite. And here's a full list. With the prime factorization of 18 on this side here, you notice all you have are prime numbers for your solution. 2 times 3 times 3, or 2 times 3 to the second power. All right, let's take a look at today's lesson, which is going to be greatest common factor. Hopefully you watched the other video before we move on with today's lesson, because the other video was also really helpful. Unit 4, Lesson 4, greatest common factor. How can you find the greatest common factor of two numbers? First, let's start with the do now. Rachel is designing a mural. A mural is like a big picture, or it could be a big painting. The mural must have an area of 42 square feet. What are the possible whole number lengths and widths for the mural? Well, that sounds to me like we need to find the factors of 42. So basically what you had to do for this one here was make a T-chart and find the factors of 42. So the possible whole number lengths and widths for the mural would be 1 by 42, 2 by 21, 3 by 14, and 6 by 7. Let's take a look at the greatest common factor. If we look all the way over to the right, we can see that in this info box it says GCF, which represents greatest common factor. Well, basically, the greatest common factor, as you saw in the other video, is a list of all of the factors for each of the numbers that are asked for, and then you find the ones that are in common and find the biggest one. That's basically it. So let's move on and look at our notes and see what we can find. The factors of a number are the whole numbers that can be multiplied together to get the product. Think factors few. Please write down the definition of the word factor, and please make sure you write down the definition for the word product. You definitely need to know both of these words for your upcoming quiz. A factor is a number that gets multiplied by another number to get a product. So a number multiplied, you should be writing this down, multiplied by another number, okay? And then the product is the answer to a multiplication problem, okay? Multiplication problem, and that's my dog Jack. All right, the greatest common factor is the GCF. The greatest common factor of two numbers is the greatest factor that two numbers have in common. There are two different ways to find the GCF. One way is using the T-charts, and the other way is using prime factorization. So what we're going to do is just look at these notes here. If you watched the other video that we had, you would be familiar with this already. So finding the GCF using a T-chart, And the steps are written right here on the side. So basically, what do? You make a T-chart for both of the numbers. So it says, find the greatest common factor of 16 and 24. So you make a T-chart for both 16 and 24. Step 2, look for the common factors between both numbers. Well, if you go through the list, you notice that there's a 1 in each, a 2 in each, there's a 4 in each, there's an 8 in each. And what you do is you find the biggest number, and you can go up and down the charts, or if you prefer, some people like to do it this way. So for 16, what they might want to do, instead of trying to look at the chart, for 16, the factors are 1, 2, 4, 8, and 16. Whereas for 24, the factors are 1, 2, 3, 4, 6, 8, 12, and 24. If you go through the list and you see the ones that are in common, okay, you would see that 1 is in common. Actually, let me get this to be a shaded. 1 is in common, 2 is in common, 4 is in common, 8 is in common. And the biggest of these is 8, and that's how you find the GCF. So the GCF of 16 and 24 is 8. Now we're going to take a look at the second method, which is going to be finding the greatest common factor using prime factorization. When finding the greatest common factor using prime factors, what you would want to do is you take each of the numbers and you find the prime factorization for it. So for example, 36, you break it down into 4 times 9, and finally you have the factors of 2 times 2 times 3 times 3. Then for 54, you would do the same thing, 6 times 9, and then you break the 6 into 2 times 3 and the 9 into 3 times 3. Now what happens is you find the ones that are shared. Now what I would like to do is this. On this side here, what I would like you to do is write them out. So for 36, 36 is equal to 2 times 2 times 3 times 3. 54 is equal to 2 times 3 times 3 times 3. Now you find the ones that are shared. Which ones do they have in common? Well, I see there is a 2 in the 36 and a 2 in the 54. So that would be a 2 times, and then are there any others that they share? So in other words, what's the common factor in the 36 and the 54? Now watch. We have a 3 and a 3, and then we have another 3 and a 3. So we list them once. So it would be 2 times 3 times 3. So 2 times 3 times 3 would be 2 times 3 is 6, 6 times 3 is 18. So that would make the greatest common factor 18. And that's how you do it. Let's look at some more examples on the next page. What are the factors of 12 and 36? List them on the T-charts below. So here you're going to use the T-chart method, and then what you're going to do for number 2 is you're going to use the prime factorization method. So let's go ahead and do the T-charts first. So for 12, pause the video and list the factors of 12 and 36. Pause now. Once you have the T-charts completed, then you're going to compare the two T-charts. Now, you do have the option of listing out all of the factors of 12 and all of the factors of 36. But what you can do is go to the smallest one first and look for the numbers in each table. So if I go to the 12 and I look and I say, hey, is there a 12 in 36? And I would say, hey, yeah. And guess what? 12 since 12 is the biggest number in the number 12 here, that has to be the GCF. So the GCF is 12 because the GCF cannot be bigger, ready for this, than the smallest number. So in other words, it couldn't be 18. Why? Because 18 is not in 12. It couldn't be 36. Why? Because 36 isn't in 12. So if you go to the smaller number and say, hey, which of the numbers in the smaller number, in this case 12, are in 36, you can figure it out. So what is the greatest common factor of 12 and 36? The answer is 12. Now let's do it using the T-chart method. Now we're going to list the factors of 12 and 36 using the factor trees. Pause the video and complete each of those next. Once you find the prime factors of 12 and 36, here we have the prime factors of 12 are 2 times 2 times 3, and for 36, it's 2 times 2 times 3 times 3. So then what you do is you look for the common or the shared factors. Well, I see there's a 2 here, and I notice there's a 2 here, so I'm going to use that, and I'm going to write it down. They don't have to be one on top of the other, by the way. They could be on an angle, so that doesn't matter. But now I see there's another 2, a shared 2 here, so I'm going to write that down, and a multiply. And then I see, look, there's a 3 and a 3. That's shared. And there's a 3. This one here, there's no match, and we're done. So the GCF would be 2 times 2, which is 4, and 4 times 3 is 12. So the GCF is 12. Now with these methods, you can decide which one you like best. Now, what are some of the differences and what are some of the pros and cons of each of them? Well, with the factors, you have to make sure that you list all of the factors in each of the numbers. So you have to be really good with your multiplication tables, with the factors, or with the T-charts. With the prime factorization, believe it or not, many students do like the prime factorization because there's a lot less work. There's a lot less numbers to list, and if you know your prime numbers, you can get to it pretty easily. But the choice will be yours, but please remember, the directions will say use the T-chart or use prime factorization. You need to be good at both. Let's take a look at some more examples. It doesn't matter which you decide to use. Either method is good. So you can pause the video. The GCF will still be the same, regardless of whichever method you use. But for this one here, I'm going to set up 18 and 36. So I have 18. I'm going to use the T-chart on this one. And I think, let's set it up together. So I'm going to use the T-chart on this one. And so here I have. Now watch what happens with this one. We have 1 times 18. Let's go to the black. 1 times 18. 2 times 9. Does 3 go in? Yep. 3 times 6. And that's it. Now for 36, 36 is a bigger number. 1 times 36. 2 times 18. 3 times 12. Does 4 go in? Yep. 4 times 9. Does 5 go in? Nope, but 6 does. 6 times 6. All right, we have a double there. We only use it once. Okay, so now we want to find the greatest common factor. We want to find the GCF, and that means what in both of these lists, what's the biggest number in both of these lists. So here's a strategy. 18 is smaller, so I'm going to start with this number here. And I'm going to start with 18. Is 18 in both of these numbers? Holy cow, look at this. The answer is yes. So guess what? The GCF is 18, and I am done. Now, if you use the prime factorization method, that would work too. Let's do number 14 together. Okay? Actually, I'm going to tell you 14. We're going to use the factor tree for this one. Okay, so pause the video and try it using prime factorization. Number 2 was a little bit easier. So basically what you're going to do there is you're going to find the prime factor. So for 14, it was 2 times 7. For 35, it was 5 times 7. Pretty basic. You list the prime factors. So the prime factors for 14 were 2 and 7. For 35, it was 5 and 7. Which one do they share? 7 is in both of them. There's nothing else, so the greatest common factor is 7. You're going to complete number 3 and 4 on your own, whichever method you like. I'm going to tell you for number 3, if you want to follow along and do what I'm doing, I am going to use, honestly, I really like the prime factorization because it's less work. So I'm going to do 22 and 55. Okay, if you want to use the T-charts, go right ahead. Number 4, I'm going to use 25 and 100. Okay, pause the video and check your work. And for number 3, the GCF was 11. And for number 4, the answer for the GCF was 25. Hope you did a good job. Let's just do a couple of more practices on the next page. So for extra practice or homework, you're going to complete 7, 8, 9, and 10. Good luck with your work finding the GCF, and this is Mrs. Patola wishing you a great day, and remember, be healthy and be kind.